Hello, everyone. Welcome to the channel. This is a story about engineering, obsession, isolation, failure, and hard-earned lessons. A few years ago, I became convinced that I could build a robot capable of autonomously trimming cannabis. So I tried. I spent months designing parts. I 3D printed prototypes. I wired electronics, wrote code, broke things, moved fast, rebuilt them, and taught myself whatever I needed to learn to keep the project moving. I never finished it. And while all of this was happening, almost nobody knew how much work I was putting into it. I barely documented the process because I wasn't thinking about telling the story. I was focused on making the machine work. So this video is my attempt to go back and reconstruct what happened, what I built, what I thought it could become, how far I actually got, why the project ended, and what I learned from taking on something much bigger than I realized at the beginning. This is the story of my cannabis trimming robot. Before I explain how this started, here's what I was actually building with. The hardware was a Yahboom robot arm, a Raspberry Pi 4, servo controllers, NEMA motors, an Octi Pro depth camera, standard trimming scissors, and an Anycubic Cobra Max 3D printer for making custom parts. On the software side, I was using Python, Raspberry Pi OS, YOLO V5, Google Colab, online tools for labeling training images, and the ChatGPT version that was available in 2023, which wasn't as great as what we have now. It was useful, but it was definitely not as capable as what we're using now with our coding agents and all the other goodies that we have. Anyhow, none of this required an industrial robotics laboratory. It was mostly consumer hardware, open source software, and technology I can actually get my hands on. Over 7 months, it went from crude experiments with a small robot and a pair of scissors to custom 3D printed mechanisms, computer vision, depth sensing, machine learning, and eventually I constructed a much larger robot arm. And I wasn't doing all of this just because I thought robots are cool. I was doing it for money. My motivation was primarily financial. I thought there was a real business opportunity in automating cannabis trimming. If I could make the machine work, I thought it could become something companies could pay for and would pay for, and potentially something that could get me out of depending on a regular job for a paycheck. That possibility is what kept pushing the project forward. But to explain why I thought this machine could actually make money, I need to explain where the idea came from. So, why was I trying to build this thing in the first place? By May of 2023, I had already spent about 7 years working in the cannabis industry. It was the best job I ever had, and at the time, I genuinely thought that I might stay there for the rest of my life. That experience also meant I had spent years watching how cannabis was produced and processed, including trimming. Trimming is repetitive manual work. A person sits with a pair of scissors and holds a bud in one hand and removes the leaves from the flower over and over again. And eventually I started wondering, why couldn't a robot do this? The machine I imagined would need multiple robotic arms. One arm would have to pick up a branch or individual bud, hold it securely, and reposition it as needed. Another arm would hold a normal pair of trimming scissors and cut away the unwanted leaves. A camera and computer vision system would need to identify the bud, locate the leaves, and determine where the scissors should cut. So the real goal wasn't just to make a robot move a pair of scissors. It was to build a coordinated system that could pick up the product, manipulate it, inspect it, and trim it automatically. I wasn't looking for an excuse to build a robot. I already understood the problem, had access to the plant material, and had a place where I could actually test it. But the biggest motivation was much simpler: money. I wanted to see if I could take an idea, build something from nothing, and turn it into an asset that generated income. At the minimum, I hoped it could become a business that allowed me to stop working a normal job for someone else. At the most ambitious end, I thought maybe I could build something valuable enough that I would never have to depend on a paycheck again. My idea wasn't necessarily to manufacture and sell robots. It was closer to robotics as a service. I could own the machines and rent them to cannabis companies, which would provide them with a automated trimming as a service. The same system could theoretically move from facility to facility and continue generating revenue around the clock for me. So that was my main motivation for doing this project. I wanted to basically create a machine that could work anywhere, and then just duplicate the machine and just rent those machines out to as many companies as I possibly could. And that possibility changed how I approached the project. Whenever I ran into something I didn't know, robotics, computer vision, machine learning, electronics, CAD, 3D printing, I figured that was simply the next thing that I had to learn. Because, in my mind, there might be a business on the other side of those problems. So the question wasn't, can I make a robot operate a pair of scissors? Because that was pretty simple and easy, and I accomplished that, the first day that I took the robot out of the box. The question was, can I build a machine that can handle the product, trim it automatically, and do useful enough work that somebody will actually pay for it? That was the idea. Now, building it turned out to be a lot harder. Building the robot arm became a constant cycle of solve one problem, create another. I started with a Yahboom 6-axis robot arm from Amazon. It gave me a cheap platform to answer the first basic question: could a robot operate a normal pair of trimming scissors? At the same time, I started working on computer vision. I trained a custom YOLO V5 model using thousands of cannabis photos I took and labeled myself. After a lot of failed training attempts in Google Colab, I eventually got the system to reliably detect cannabis buds. But detecting something in a 2D image wasn't enough. The robot also needed to know how far away it was. So I upgraded to an OAKD Pro depth camera. The Raspberry Pi 4 connected everything together. The camera provided the input. Python processed the detection. And the Raspberry Pi controlled the motors and servos. Eventually, the system could detect a bud, check its distance, and automatically activate the scissors. That was the highest level of autonomy I reached. The robot could see cannabis and react to it, but it couldn't identify individual leaves, determine where to cut, or autonomously trim an entire bud. From there, I started designing more of the hardware myself. I bought a 3D printer, learned CAD, computer-aided drafting, and built a dedicated scissor mechanism using a stepper motor, gears, and standard trimming scissors. Eventually, the Yahboom arm was too small, so I began building a larger BCN 3D Moveo robot arm. And the files for that are on GitHub. You can check it out, print it out yourself, and build it. It does require some hardware though. I modified the base to make it taller, which also made it heavier and more mechanically complicated. Then I fried the Arduino and motor control electronics while wiring it. By this point, I was learning robotics, programming, computer vision, machine learning, electronics, CAD, and 3D printing at the same time. I had built a lot of the individual pieces. But the machine I imagined was much more ambitious. Multiple robot arms working together, one holding and repositioning the plant while another identified individual leaves and trimmed them automatically. I never got that far. I had proven that parts of the idea could work. I never got the chance to fully connect them. While I was building the robot, I was doing almost everything alone. At the time, that seemed reasonable. My goal was simple: finish the machine. Every hour spent documenting the project, posting online, or explaining it felt like wasted time. But this project required mechanical design, electronics, programming, computer vision, machine learning, robotics, and system integration. Every time I hit a problem, my solution was to learn enough to solve it myself. That worked for a while, but it was very inefficient. I was trying to build a highly multidisciplinary machine while barely connecting with people who already had experience in those fields. I posted the project online a few times, but it got almost no attention. No comments, no messages, nobody wanting to help out, and basically no positive or negative feedback, either way. Instead of trying harder to build a network around it, I went back to working alone. I also documented very little. At the time, failed prints, wiring problems, prototype changes, and small breakthroughs just felt like obstacles on the way to the finished product. Looking back though, those things were actually the story. More importantly, documenting the project could have helped me find collaborators, feedback, or people who could solve problems much faster than I could. I thought I only needed to build the robot. What I really needed to build was a project around the robot. And because I didn't, almost everything depended on me, and on my circumstances staying exactly the same. Then, in January 2024, things changed. At this point, the project was still active. I had fried the Arduino and motor control board on the Moveo, ordered replacements, and was working on smaller things while I waited. One of the last things I did was organize and wrap the robot's wiring. I wasn't winding the project down. I was expecting to install the new electronics and keep going. Then I was terminated from my job, and I stopped working on the robot that same day. The problem wasn't just losing my paycheck. I also lost access to the environment the project depended on. My job gave me access to real cannabis plant material and a place where I could test the robot against the thing it was actually designed to work with. I could still write code at home. I could design parts, 3D print components, and work on the electronics. But eventually the robot had to interact with real plants. Could the camera detect the bud correctly? Could the depth camera determine where it was? Could the robot position the scissors accurately? Could it actually make the cut? And because every plant is different, those tests need to happen over and over again. And when I lost the job, I lost that feedback loop. The question went from, how do I solve the next engineering problem, to, where can I even run this experiment? The project didn't end because I proved the idea wouldn't work. It ended because the circumstances that made it possible to keep developing it disappeared. And looking back, that exposed another problem with how I had built the project. Everything depended on me, one workplace, and one source of access. There was no team, no backup testing environment, and no other path forward if those conditions changed. I'd spent all this time thinking the hardest part was building the robot. And eventually I realized that building the robot was only one part of building the project. Looking back, the biggest thing I would change is simple. I would build a team. My approach to every problem was basically, I don't know how to do this, so I will learn. That got me far, but eventually I was trying to learn robotics, electronics, computer vision, machine learning, computer-aided drafting, and mechanical design all at once. If I did it again, I would spend more time finding people who already knew how to solve those problems. I'd probably spend more time at colleges or places where people were building robots and talk to them about my project. I would also document the project publicly. At the time, documenting it felt like time taken away from building. But now I realize it could have helped me find collaborators, get feedback, and attract people with skills I didn't have. From an engineering standpoint, I would keep the prototype smaller, validate each subsystem before scaling up, and avoid making the entire project dependent on one testing environment. Because when I lost my job, I didn't just lose my paycheck, I lost access to the real material the robot needed for testing. That taught me one of the biggest lessons from the project. Building the robot was only one part of building the project. You also need the right people, the right environment, and a way to keep going when everything changes. And I only understand that now because I actually tried. And looking back, I think the whole project only existed because a very specific set of circumstances came together at exactly the right time in my life. And this was like lightning in a bottle. And I don't think I'm ever going to have this situation. Um, Looking back, this project really was lightning in a bottle. For a short period of time, I had the industry experience, access to the plants, the technology, and the motivation to try something I probably never could have attempted under normal circumstances. And my goal was never just to build a cool robot. I wanted to take an idea, turn it into something valuable, and build a business around it. Something that could eventually generate recurring income and free me from depending on a normal paycheck. I never finished the robot, and I never found out whether that business would have worked. But I did take that opportunity seriously. For 7 months, I pushed it as far as I knew how. And there's a line from the great American philosopher Eminem. You only get one shot. Do not miss your chance to blow. This opportunity only comes once in a lifetime. And I don't know if this was really my one shot, but it was one of those rare moments where everything lined up. And I hope that when the next opportunity like that comes along, I recognize it and I take the shot again.